This is section 7.6, number 34. Let's run through this, see what's going on. So I've got a 1 plus 1 over cosine theta is equal to tangent squared of theta over secant of theta minus 1. On the surface, you might be thinking, oh, I'll switch this into a secant of theta. But I actually picked up on something on the other side. Tangent squared of theta doesn't directly link to that, except, remember, we have an identity, one of the Pythagorean identities, that says that the secant squared of theta is equal to the tangent squared of theta plus 1. And that means that tangent squared of theta is equal to secant squared of theta minus 1. And I'm thinking, you know, that would sync with that pretty well. Just in general, if I see a secant squared or a cosecant squared or a tangent squared or a sine squared, I always check and see if I can do something with one of the Pythagorean identities. I'm pretty sure that's what was intended here. So I'm going to replace tangent squared of theta with secant squared of theta minus 1. And we've got the 1 plus 1 over cosine of theta on the other side. All right, so these look a lot alike, but not quite the same because the top is squared, okay? Well, we've already seen this, I think, in one of the other videos. That's a perfect square. 1 squared is equal to 1. This is a difference of squares. So I can factor that as secant of theta plus 1 times secant of theta minus 1. And notice there's another secant of theta minus 1 in the denominator, and we can get a whole bunch of simplification really, really quickly here, okay? I can divide secant of theta minus 1 out of the top and the bottom, all right? So that's going to leave me with 1 plus 1 over cosine of theta is equal to secant of theta plus 1, okay? Not exactly the same thing, but that's 1 over cosine, and we already had a 1. So 1 plus 1 over cosine of theta is going to be equal to 1 plus 1 over cosine of theta. Just like that, number 34 is done.